Hi everyone. In today's video, I am going to be showing you how to use a proforma to solve a compass error calculation. Alright, so we will use a proforma and we'll solve the compass error calculation. So if you don't know what is the proforma, I can show you what a proforma looks like. So this is what a proforma looks like. So that means that there is already the text part is already written to save the student's time, and all you have to do is basically fill in the values and get the answers in the end. So it saves a lot of time. The proforma also mentions a lot of formulas that you need, so that will be beneficial for you as well. You don't have to rely on your memory to remember the formulas, so you can use the formulas. You can just straight away apply it in your calculators and get the answer. All right, so this is what I will show you today. So I'll go back to the question, I'll show you the question, and then I'll show you how to fill up the values in the proforma. So the question is that it's October 25th 2004. So you'll need the 2004 almanac. Even if you don't have the almanac, you can just see the principles behind filling up a proforma. It's pretty much the same irrespective of what year of question you're doing. So you have the DR position, or the dead reckoning position, of 45 degree 50 minutes north and 142 degrees 15 minutes west. The celestial body is Sun, and it was observed to be a 220 degrees compass. We'll be using the azimuth method of compass error calculation, just to make it very clear. The chronometer showed the time 00:29:00, so that is 00 hours 29 minutes 00 seconds, and the chronometer error was nil. There was no chronometer error. The zone time was GMT minus 9 hours. So of course you are in west longitude, and if you are in west longitude, you are running behind GMT. GMT is ahead of you, so the zone is -9 based on your longitude. And so then you also have to note down the zone time was approximately 1529 hours. So the zone time is the time that you keep on your watch or the ship's clocks, is 1529 hours. So that's like a hint. This is an important hint that you have to remember, which will help you to determine the GMT time from the chronometer time. And then the question is, find the deviation of the compass if the variation was 10 degrees east. So the deviation is what you have to find, and the variation is given to you. So how would you go about using the proforma to write down the answers to this? All right, so make sure you note down these values, because after this I will not be coming to this screen here. I will be working only on the proforma. So let's get started with the proforma. So this is the proforma. So let me show you how you start filling up the proforma here. So the proforma says initially you start off, you can write down the dr, lat and long if you want to. So you have 45 degree 50 minutes north here, and you have 142 degrees and 15 minutes west that you can write. All right, of course the celestial body is Sun. You can also use this proforma for planets, and for stars also you have a similar proforma, except that you will have maybe some addition as well. All right, so don't worry about the star right now. If I show you one, I'm pretty much sure that you can use the star proforma as well. All right, so first thing you have to do is write down the chronometer time, which is given to you as 00. Oh, so that's the date, sorry. So that will be 25th of October. So you can write the date first. So write the date 25th of October, and the hours is 00, minutes is 29, and seconds is 00. Right, the error is nil, so nothing here. So that means you get a GMT time of 25th of October 00:29:00 hours. All right, now how do I know that this is the correct GMT time? Now the hint given to me in the question is that my zone time is 1529. All right, and my GMT, or the zone correction, is -9 hours. All right, so how can I use this information to confirm that this is the correct GMT time? So here the GMT time has two options only. The GMT time can either be 00:29:00, or it can be add 12 hours to it, 12:29:00. So when you see 12 o'clock in the ship's clock, that 12 o'clock could be 12 o'clock in the afternoon, or it could be midnight, right? That's the thing with chronometers. So the option is only two. It's either 00:29 or 12:29. Then what you do is you apply your zone correction of -9 hours, which is given to you in the question. It's 09:00:00. You can also find the zone correction. I just draw a line in between so that you guys don't get confused. So you can also find the zone correction by dividing the longitude by 15 and making it a whole number. So if you divide 142 degrees 15 minutes, so you can do that on your calculator along with me and divide it by 15. So divide the longitude by 15, you get 9 hours 29 minutes. Now because it's 9 hours 29 minutes, 29 minutes is less than 30 minutes. So what you will do is the zone is then 9 hours. It's -9 because you are in the west longitude. If you are in the east longitude, it would have been +9. And if it was 9 hours 31 minutes or 9 hours 35 minutes or 45 minutes, then the zone would be -10. Anyhow, so the zone is given to you. So once you subtract 9 hours, what is the zone time you get? The zone time you get in the first case is 15:29:00 and the second case is 03:29:00. Right? So how do I know which is the correct GMT time? Now the zone time is 25th of October 15:29. This is given to me in the question. So 25th of October 15:29 is the zone time. And this is the case where the zone time matches the one given to us in the question. So I will cancel this out. But if this is 25th, if the zone time is 25th 15:29 on the ship, and you're subtracting 9 hours from GMT, which is past midnight, that means the date of GMT is no longer 25th, it is 26th, right? Because it's past midnight. So only when it's 26th past midnight, you subtract 9 hours, the zone time would be 25th 15:29. Because the question says it's October 25th on your vessel and the zone time is showing 15:29. Alright, so therefore the GMT, at GMT it is already 26th of October. It's no longer 25th of October in GMT because GMT is 9 hours ahead of you. So what would you do? You would change the date here. You would make it 26th. So in the Proforma, you will make it 26th October. That's your GMT because this is the time you will use for the rest of the calculations to get the values from the nautical almanac. Alright, so you can pause the video here, understand it further. Remember, the question says it's October 25th, 2004. Alright, it's October 25th, 2004 on your ship and it's 15:29 on your ship. It doesn't say it's October 26th, but at GMT, which is 9 hours ahead of you, it's October 26th already. They are past midnight, so the date has changed. I'm just repeating myself because I know some of you will be confused here. Alright, now that you have found out the GMT time, alright, you go into the nautical almanac for the 26th of October, not 25th, but 26th of October, and you find the GHA, the increment, and you don't need V correction. This is for planets only, so don't worry about that. And then we'll find the declination and all that as well. So what I'll do is I'll go into the almanac once and I'll show you all the values, and then I'll come back and fill these values here. I don't want to go to and fro because in my other videos I've shown you how to find GHA and declination and D value, D correction, all that I've shown you. So I don't want to waste too much time there. You can learn how to get the values from the other videos. This video is purely for using the Proforma. Alright, so let's get into the nautical almanac for 26th of October. There you go, that is 26th of October. So if I zoom in here, you can see at the top you have 26th of October written there. Very good. So you have to go into 26th of October, not 25th of October, but 26th of October, right? So 26th of October, if it's a sun question, my sun is here, right? And the GMT time, remember what is the GMT time? The GMT time is 00:29. So if I zoom in here, 26th of October, I'm just trying to zoom in and show you the value. So this is 26th of October 00, but I have to see it for the sun. Here you go. So I can show you both the things together. All right. So my GHA is here 184.00.1. My declination for 00 hours is 12:29 minutes south, but that is for 00 hours. I need it for 00:29. So what do I need to do? I need to go into the increments page and find a correction value. How do I find the correction value? Well, I note down the D value at the bottom of the declination table, D value of 0.9. And I will take this D value of 0.9 and go into the increments page to find the correction. What else do I need to see is the declination as I'm going from 00 hours to 01 hours. The declination value is increasing. So once I get the correction, I will be adding the correction value to the declination value. If my declination was decreasing to the next hour from 00 to 01, then I would have subtracted. Alright, so declination is increasing. So what I'll do is I'll come out of this page, and what I'll do is I'll go to the increments page for 29 minutes because that's the minutes I needed for, right? So 29 minutes is here. So this is 29 minutes. This is for sun and planets, but I need my declination correction for 0.9, which is here, for which the correction value is 0.4. So I will take the 0.4 and go back to the almanac. So go back to the Proforma. So this is how I find the values. I don't want to waste too much time here. Like I told you guys, this video is about teaching you how to fill the Proforma. So I go back to the page and I will write down all the values I showed you guys before. 184 degrees, 0.1 minutes. Okay, the only thing I forgot to show you was the increments. So how do I get the increments? So for increments as well, you go back to the almanac, you go back to the same page for increments. So increments for 29 minutes and 00 seconds is here, given here. So increment is right here, 7 degrees 15 minutes. All right, 7 degrees 15 minutes is the increment. So that is the only thing I forgot to show you. I go back to the almanac and then I write down here in the increment section 007 degrees 15 minutes. So the corrected GHA becomes 191 degrees. So increment is always added. Okay, so the word increment itself means that you should always add it. So 191 degrees, am I correct? And 15.1 minutes. This is the correct GHA. Now your longitude is what? Longitude is 142 degrees 15 minutes, and it's west longitude, not east longitude. The rule of thumb is longitude west, GHA is the best. So that means GHA will be more than LHA. So longitude west, GHA best, GHA will be more, so you will subtract it. If it was longitude east, GHA would have been least and you would have added the longitude. Alright, so once you subtract it, what do you get? You get 49 degrees and 0.1 minutes. That's your LHA. The rule of thumb for LHA, if it's 0 to 180, it is, what is it? It's west. Alright, greater than 180 to 360, your LHA would be east. So in this case, your LHA is west, not east. This is important to us because later on when we are naming our A, B's and C's, you will realize it's important. Alright, then I showed you how to get the declination value, so I don't want to repeat myself again. So it was 12 degrees 29 minutes south. The D value was 0.9. The D correction I told you will be added because the declination was increasing as I was going from 00 to 01 hours. So for 0029, it should be more than what you have at 00. So you will add the correction. So declination value for 00 hours, 29 minutes, 00 seconds is, of course, it was south. So I don't need north. So it will be 12 degrees, 29.4 minutes south. All right. So that's simple. Then you keep going. Then what you have to do is you have to find the value of A. Now the formula for finding A is tan lat divided by tan of LHA. And how do you name it? You name it opposite to the latitude, except when your LHA is between 90 and 270. Alright, so here is your LHA between 90 to 270? No, it is 49 degrees, which does not lie between 90 and 270. So that means you will find A and you will name it opposite to latitude. So your latitude is north, you will name A opposite to latitude, south. So do tan lat by tan LHA in your calculator. So put tan of latitude 45 degrees and 50 minutes in your calculator. Please do it with me. Divided by tan of LHA. What is LHA? 49 degrees 0.1 minutes. All right, so what you get is 0.89 in your calculator. So you get 0.89489572996. You can limit it to 2 decimal places. The more you go, of course, the more accuracy, but time constraints, keep it to 2 decimal places if you have to. And then you find B, and B is found by dividing tan of declination. Tan of declination 12 degrees 29.4 minutes. All right, and divided by sine of LHA. So sine of LHA, what is LHA? 49 degrees 0.1 minutes. When you divide it, you get 0.2934982721. Just keep it to 2 decimal places. So you keep it to 2 decimal places. Now we have to name A and B. Remember, in any case, when you get A and B as negative in your value in your calculator, you will ignore the negative sign. You will only write the positive values and you will name it. That's how you will add or subtract it. You don't include the negative sign. Ignore any negative sign you get for your A's or B's or even C's. So A was named opposite to latitude, so I will name it south, and B is named same as declination. So I will name it same as declination south. Then what is the rule of finding C? Same names, add, different names, subtract, and then name of largest. So here they are same names, you will add the two. So when you add the two, you get 1.18. And you will name it south because both are south, so you will name C south. The next thing you have to do is finding azimuth. So how do you find azimuth? Tan of azimuth is equal to 1 divided by C times cos lat. Now in your calculator, you have to make sure you include the brackets, the parentheses. You cannot type in your calculator 1 divided by C times cos lat, you will get the wrong answer. Alright, so you have to include the brackets, otherwise you will get the wrong answer. So you do 1 divided by, so I am doing it together with you, 1 divided by, put in the parentheses, what is C? C is 1.18 multiplied by cos of, what is lat? 45 degrees 50 minutes. All right, and what you get is 1.216304525. Then shift tan inverse, what do you get? 50.5 or 50.57. You can make it 50.6 if you want to. So you get 50.6. How do you name azimuth? Azimuth is named name of C and LHA. Name of C and LHA. So C is named south, you will name it south. And LHA, remember I told you this will be handy later on. So LHA is named west, you will name it west. So what is south 50.6 west? That means if this is south and this is west, somewhere here. So south is 180, west is 270. South 50.6 west means you went west from south this way by 50.6 degrees. So what does that mean? You will add 50.6 to 180. Alright, because as you are going from south to west, your value is increasing from 180 to 270. So you will add 180 plus 50.6 and your true bearing will be 230.6. Alright, that is your true bearing. Remember that. That is your true bearing. Your compass bearing is given to you in the question as 220 degrees compass. 220 degrees compass. Right? So therefore your compass error will be 10.6 degrees. And how do you name it? Compass best, error west. So that means compass is more than true, error will be west. Compass is less than true, error will be east. So compass here is less than true. So your error will be east. So compass least, error east. Alright, you can remember it like that. Otherwise, I'll show you later on how it means in terms of the drawing as well. I have shown all that in my previous video, so I don't want to make this video unnecessarily longer. And then your variation is 10 degrees east, again given to you in the question. And you know that variation and deviation both together make up for compass error. So if your variation is 10 degrees and error is 10.6, your deviation would be 0.6 degrees east. Alright, so variation and deviation together make up for compass error. So variation plus deviation is giving you the compass error, it's east. So this is how you will find the deviation, 0.6 degrees east. Alright, before I go, I'll show you how this means in terms of drawing as well, because being a lecturer, I can't help but show you in terms of drawing. So this is what it means. So if you want to remember how to find out, so see, this is your 230.6 was your true bearing, right? Your compass bearing is 220. Let's say I'm just trying to make it, give it big angles so that you can see. So because your compass is lying on the east of true, your compass error is 10.6 degrees east. All right. And then what is variation? Variation is nothing but the angle between true and magnetic. So your variation is 10 degrees east. That means your magnetic is lying 10 degrees to the east of, this is your magnetic. This is lying 10 degrees to the east of true. That is variation. And what is deviation? Deviation is nothing but where your compass lies with respect to your magnetic bearing, which again lies to the east of the magnetic. Alright, therefore this is 0.6 degrees, because from true to compass it was 10.6. So that's what it means in terms of visualizing or drawing it conceptually. If you don't want to use the TDM-VT rule or the cadet rule, I don't know, there are so many rules you guys follow. I like to understand it conceptually. Alright, so I'll stop the video here, guys. I hope this was useful to you. I'll see you soon with my next video where I'll show you using the Proforma for intercept questions. Then I will show you more uses of Proforma for star questions, planet questions, just to understand it further, to make it beneficial for you guys. All right, good luck and thanks for watching. Thanks for supporting the channel. I look forward to your feedback.